Right.
5 minutes.
Thanks. All right, don't worry about it. Although my name is Dr. Killer, gladly I didn't go into medicine, so everything's fine. Just doing some computer science here. All right, confidential and distributed agent indexing with Acurast and the NANDA registry Quilt. So as you can already read from that, our expertise goes into confidentiality and also distributing things that are in contact with the registry Quilt, because everything is interconnected and not hierarchically organized. So as you can see here, Acurast can actually empower this interweb of connections where we can have different entities such as NL web agents, decentralized agents, whether they exist or are used today. That's another discussion. IoT agents definitely exist and are used, enterprise agents as well. So Acurast can sort of interconnect all these things by providing compute, routing, and storage. Because we have a decentralized network of around 100,000 devices globally, fully distributed, decentralized. Why do we use phones? So that's usually the first thing people ask. I realized over the course of the last 3 years, it starts to diminish a bit because people start to realize that the phones are actually really powerful and secure. They're also decentralized by design because there are, I think, last year it was 1 billion less phones than humans on Earth. So I guess next year, since we sell around 1 billion of phones per year, that should be more phones than people on planet Earth, which is kind of crazy. And also through the average lifetime of a replacement cycle of 2.75 years, that means that we certainly will have more phones than people right now. So also they are verifiable by design, meaning that I'm going to refer to our colleagues of Secret Network and Fala as well. They use trusted execution environments as well. We use them too, but we go on a hardware level, meaning that depending on the device, we actually bootstrap a trusted execution environment. For example, if it's a Google phone, Titan coprocessor, we really do that on an Android level. And then that makes it really secure, just as if you would leave your phone locked somewhere. You also trust that nobody can extract information, right? Whether or not that's possible, that's another discussion for a beer or a coffee later, because that goes into the tin hat foil section, and we're not going there right now. So, and that also means it's confidential by design, because we have that trusted execution environment, and of course we have lots of other protocols in place to achieve security. Now, taking a direct reference to the NANDA Quilt is, for example, if a user would have a query that would go through the Acurast processor, and also with all the metadata or agent facts, we can actually do adaptive routings, which then select the optimal node based on latency, throughput, or whatever kind of metrics you choose, right? And that, of course, is returned to the user. On the bottom, you can see a verification process with verifiable credentials, for example, where an agent provides these. Then they pass through some sort of consortium or the consensus mechanism. We use DPoS, so we use delegated proof of stake. So who was it before? Let's catch up later and discuss whether or not that makes sense. I think economically incentivizing security in an adversarial network is a way to achieve security, right? I think this has been proven many times over again, and I don't know any other way on how to do that right now. Also, Nakamoto consensus is the best way to achieve that, but that's another discussion as well. So as you can see here, trust verification can also be covered. And then here, I'm going to cut this very short because this is also something that we as engineers first thought about, of course, that we can develop standardized protocol adapters, have a pilot program, and then also optimize for performance as well. And then when everything is in the real world, we need to think about compliance as well as governance as well. So thank you so much for having us.